Hi everyone. Today I'll be talking about hydroelectric power, where we can convert the flow of water into electricity. And perhaps the most common way that we can do that is by creating a dam. I got to take a trip a few summers ago to Bosnia, and we were driving along the river. And there's about 13 dams that are built along the river. And then these dams are built there for hydroelectric power. And then the picture on the left, this was just a man made dam, not necessarily to convert into electricity, but just as a recreational space. So, in terms of how hydroelectro dams work, you need a reservoir. So you need a large body of water on one side of your wall. And so that wall, that would be like the dam. It's blocking the natural river water flow. So this dam, it raises the water level to create a falling water effect. So when we need energy, essentially what you do is you would lift up the walls of the dam, you're going to let the water flow. And that water, once it flows, it's going to spin the turbine. And so a turbine's like a big fan. And once that turbine spins, then it's going to power the generator. Then in turn, with a whole bunch of physics words that you'd have to ask your physics teacher about, then that can create electricity. But for our class, essentially what you need to know is you need to know that once this turbine spins, it will be able to power the generator, which then in turn will provide or produce electricity. And then these turbines, they're not small. And so this is an example of a turbine. So you could see like this is one person, this is another person. So they're very, very, very large. Another way that we can produce energy from water is not only through a dam, but it's through tidal energy. So tidal energy, like the tides, like waves. So this is similar to an underwater windmill, and essentially it will harness the motion of the tides, so like at high tides and low tides, to turn the turbines. So if we're looking at this picture here, land is on the left, the ocean's on the right. During times of high tide, this wall or this section right here will be open to allow water to go to the left. And then that wall will be closed. And then in times of low tide, where the water level is lower, then you can open up this wall or this section right here, this gate, and then the water can flow, right, due to gravity. And then here the turbine will spin, and then the generator will be able to produce the electricity. And here it says it works best at strong tidal zones, and it's completely renewable. It produces no emissions because all you're using is the power of water. So you're not burning any fossil fuels or anything to get this to work. It's just gravity, just water. There are different types of hydroelectric energy. So with going back to the dam, it's generated by the force of water. So it can only be used near a flowing river or a flowing body of water. One of the kinds of the dam called run-of-river hydropower is, if we're looking at this picture on the left here, instead of completely blocking off the river, like the picture that I showed you from Bosnia, the picture on the right, not the homemade one, instead of completely blocking it off, you're diverting some of the water. So diverting means you're creating a channel, digging it so you're not totally blocking the original natural flow of the water. So run of river, it provides a continuous generation of electricity, but it will have little or no storage facility. So that storage facility, like the original one, would be if this water here was completely blocked. And so if this water here was completely blocked, then you would have a large like pool, a large reservoir of water like behind that wall. But here, if we're only taking off or only siphoning off a little bit of water, portion of the water, you don't need to have that storage facility. And here it says channels the water from a river to a canal or a penstock to spin a turbine. So over here, another turbine, another generator. Then the picture on the right here, offshore hydropower. This is when you're talking a little bit more about the tidal currents or the power of the waves to generate electricity and power. And if we're thinking about maybe looking at these buoys, so these buoys, you can also have little generators here, okay, depending on the motion of the waves in the ocean. Another example of hydroelectric energy, so another example would be pumped storage hydropower. So pumped storage hydropower uses a pump. It uses a pump. It harnesses the water, which is cycled between lower and upper reservoir by pumps that use any extra energy when the demand is low, and when electricity is high, the demand of electricity is high, the water is released back into the lower reservoir through turbines to produce electricity. Okay, so what does that look like? If we're just looking at here, you have an upper reservoir. So think about in the mountains. Okay, so you have a whole bunch of mountains here. You have a reservoir of water. So you have like a water storage. And then down the mountain here, you have a lower reservoir. So now you have that difference in altitude, or you have that difference in gravity. So when you allow the water to flow from the upper reservoir to the lower reservoir, it then can in turn spin the turbine, which will spin the generator. Storage hydropower. Storage hydropower, this is our traditional when you think about a dam. And so this is the large dam. It stores water in the reservoir, and electricity is produced by releasing water from the reservoir through the turbine, which activates the generator. And it can be shut down and started up at will. And it offers a high storage capacity for energy, which we'll show you pictures in a little bit. So the benefits of hydropower, all the different kinds of hydropower, it's a way that you can control flooding because you're limiting the amount of water that can be passed through. You're not producing any waste products because you're not burning anything. That the fuel itself is water, and then you're just using that water to spin the turbine. It's long lasting construction wise. Right? But as you might recall from our discussion assignments or our town hall meetings before, there could be problems, right? But it does last a long time. And it's also very efficient, right? It's moderate to high net, it's useful energy. So it's very efficient in terms of the input versus output. And then it reduces the consumption of fossil fuels for energy production because it's not burning anything. Other benefits, it's an area of water recreation. So you can go kayaking, you can go canoeing, you could go swimming maybe. It depends on what you want to do. Also, along the sides of the river, you can go fishing and things like that. It also provides water for irrigation because you have a large reservoir. And so if you have a large reservoir, then you can siphon off some of that water to irrigate crops. And it's low in maintenance costs because it's just water, right? So nothing toxic about it or anything like that. So with dams, there's also, problems. So with every type of energy source, there's always pros, there's always cons. And the problems with hydropower is it will destroy wildlife habitats. It prevents the migration of fish because if we're thinking about the dam, if we just build a wall, right? You're building a wall, you are blocking the passageway of aquatic organisms to go one way or the other. And there's also something called sedimentation. So sediments, we've talked about sediments, I think, for the soil lab. So sediments, just small particles like sand, right? When the water flows, okay? So water doesn't just transport the aquatic animals, it also transports the stuff at the bottom here. So you're going to see sand move. You're going to see silt move, maybe even clay move, and it's going to move naturally downstream. And then what ends up happening is because you have that wall, instead of all of that sediment, instead of that sand, that silt, that clay moving to the bottom, it gets stuck, right? It gets stuck because it's not going to go over the dam. So it gets stuck here. And then if enough builds up, it gets very heavy and it could start to crack the dam. So other problems, the sedimentation, it requires dredging. Okay, so what is dredging? Dredging means you just have to scoop out the sediment, which can get costly. It's also expensive to build. So the initial startup cost is quite a bit. And these large scale projects are subject to earthquakes. So just in case there's an earthquake, right, you have a large concrete wall, it could crack. So you don't want to necessarily build a dam in areas of high earthquake activity. Other problems, it destroys the wild rivers, right? Because you're blocking stuff away or stuff off, preventing water to flow, preventing everything else to flow that's in the rivers. And it will create a large flooded area behind the dam. Right? So we're talking about that large storage space, that reservoir. In order for that large storage space or reservoir to be created, you have to evacuate people. So you have to evacuate people. So imagine that this is the wall, this is the dam, and then behind this, you need like a big pool So that big pool is going to be wider than the width of the normal river. So you have to move people out of the way. And then because you're now blocking the natural flow of the river, this slow moving water, it could make the breeding of pathogens easier. You might have more stagnant water. And there could be also water loss due to increased evaporation because you have a larger surface area. Going back to fish. So with the dams, it results in the decline of fish populations in streams because they're unable to swim through it. Right? They're also they are also unable to swim upstream due to the dams. And I would say a very famous example that you're going to read about is salmon. Okay? Salmon and other anadromous fish, they only breed in the area that they're hatched in. So salmon, they are born in freshwater. But when they want to, when they grow up and they're going to eat and live their life, they actually go to saltwater areas. So they're going to go to the oceans. But then when they want to lay their eggs again, they're going to go back to freshwater. So the problem is if you're building a dam, okay, so if you're building a dam, then they're unable to travel upstream. And it says here, fish that spawn in normally silty river, okay, silty as in like there's lots of silt and lots of sediment, they no longer have a place to no longer have a place to do so, excuse me. And one I guess solution that humans came up with is to build this fish ladder. I feel like we talked about fish ladders before, but an example of the ladder is over here on the bottom right, over here on the side. So you'll see that here's the dam, here are the turbines, and there's a little section that's kind of carved out for the fish to swim upstream. Okay, so right over here, I got to see an example in Seattle, and they kind of made it like a tourist attraction. So there are salmon that end up going upstream, but you can see like it's not a natural upstream, right? It's like you go straight, then they have to like turn and then turn again. Are fish gonna know that, okay, let me swim to the side here, and then I know to go up, up, and turn and go up? Some do, some don't. When I went to go see it, not all of them were alive in the little like viewing area. So just wanted to let you know in case you've never seen a salmon ladder, a fish ladder before. It's a great idea. Great idea in terms of 100% efficient. Not exactly, but it's a way. It's a way, right? So just think about like the pros and the cons, right? So pros with just the part of water, okay, just using water. Cons, there's always going to be cons. Right? So you just have to think about pros versus cons. You know, what's better for the environment, what's better for sustainability. And then if we're looking at the usage rate over the years, global hydropower consumption has gone up, right? So in China, hydroelectric power generation, a lot, a lot, a lot. And then if you wanted to read more, you can take a look at this article. So perhaps the most famous, the largest dam that was built is the Three Gorges Dam. So it's the world's largest hydropower plant in China. It had to displace 1.2 million people because you need a big, big reservoir. And it altered entire ecosystems. And because you're diverting the water from different places, it has contributed to the desertification and the spread of the Gobi Desert. But it produces so much power, 18,000 megawatts of power. So hydropower versus solar power. Right? So hydropower versus solar power. Hydropower is more reliable than solar energy because solar energy only provides energy with direct sunlight. Right? And then for solar powers, its advantage, is its simplicity as it doesn't require any turbines. Right? We just have these panels, and this will be able to give us electricity. Hydropower, it's not usable on smaller devices such as phones and calculators as solar power can be used. So you probably even at one point in your life, maybe not this model, but if you have used a solar power calculator before your cell phones or laptops. And then there is still a way where water can create electricity. So if you want to click this link, this is a water clock. So water clocks, all you need is tap water. Okay? So all you need is tap water. So the tap water is enough to create an electrical current, but not distilled water. But that's more of a chemistry thing. All right, and then hydropower, it can create a recreational space, which we talked about. And this last slide is just talking about some fun facts about hydropower, which I'll let you read on your own. And that is all. Thank you for listening.